All right, this is the introduction to chapter 8. It is the magnetic force. So we're going to see in this chapter, we're going to be talking about the magnetic field, the magnetic force, and its effect on a moving charge. Now we will see right away that the magnetic force, in order to define the magnetic force actually, we will need to define it in 3D. Now, this is a college level course and we will not develop the mathematics to deal with 3D vector. Instead, what we're going to do is we're going to use a clever trick in order to simplify these type of problems. So before we talk about this trick, let's just define the magnetic force. So the magnetic force, F vector, magnetic, is equal to the charge, so it has to be a moving charge against a magnetic field, multiplied by the velocity vector cross product the magnetic field vector. Now this term is a big computation, okay, and I'm not gonna have you do it. We are going to simplify this value here, and this is what these two brackets are. These two brackets tell us that that this formula is equal to the magnitude. So the magnitude of the magnetic force is equal to the magnitude of this cross product over here, and it is equal to the charge multiplied by the magnitude of the velocity multiplied by the magnitude of the magnetic field, sine of the angle between these two. All right, now note B is our magnetic field. It is in the unit Tesla, and in the first few examples, I'm going to talk about the magnetic field. And in the next chapter, we're going to be talking about the source of the magnetic field. So where does it come from? So in this chapter, we're using a different strategy. We're simply saying, okay, here's the magnetic field. Here's what the effect of the magnetic are on a moving charge. And in the next chapter, we are going to state, well, where does this magnetic field come from? All right? Now, because we're going to be dealing with 3D vector on a 2D surface, so basically you can draw 2D vector on a board like this, but if you need to represent the 3D vector, you need something else to determine is the third vector going into the board or out of the board. So we need to create some new notation. So these are the two new symbols we are going to be adding, and this one over here, a circle with a dot inside, represent that the vector is going out of the page. So it's going, in my case, out of the whiteboard, so it's coming toward the camera in this case. The second symbol, a circle with a cross inside, state that the vector is going into the page, or into my board in this case. Obviously, from your point of view, writing on a white piece of paper, this state that it's going out of your page, this one is going into your notebook, all right? So you will probably need some practice with these, and we got a lot of example just to warm up to these new concepts. All right, so if we go back to the first part, we have this formula here that tell us the magnitude of our vector, the magnitude of the magnetic force vector, all right? Now we need a way to determine in which direction this vector is pointing. And we're going to use something called the right-hand rule. So disclaimer, there are many different variations of the right-hand rule. I'm going to use the one I'm most familiar with, all right? So let's say if we take the charge over here, flip it on that side, we got the magnetic force divided by the charge. Now note the charge is a scalar number. It does not affect the direction. So this vector is still pointing in the same direction, all right? The magnetic force divided by the charge is equal to the cross product between the velocity vector and the magnetic field vector, all right? So what we do is we take our right hand, we point our finger in the same direction as in the velocity vector, we curl our finger toward the magnetic field vector, and our thumb would be pointing in the direction of the magnetic force. All right, so let's just do a simple example here. I got two vectors here. Both vectors are directly on my whiteboard, all right? We got the velocity vector pointing in the right direction. So I point my finger in the right direction. The magnetic field is pointing upward. So I curl my finger upward, and you see my thumb is pointing toward the camera. So in this case, the magnetic force will be pointing outside of the whiteboard, or if you were writing it on a sheet of paper, will be outside of the page. All right. Now again, I know this will be confusing at the beginning. We got a lot of examples just to practice this new concept. All right. So in the next video, we're going to be talking about the Lorentz force and what happened when a charge moves in a perpendicular magnetic field. We will see that it will follow a circular motion. All right. So in the next video, we're going to tackle these concepts. See you there.